Kendall will watch it for sure. Sorry, Kendall, we forgot the first couple problems, so I'll at least put these up here so you can look at them. Let's not start over. We have 12 minutes. Okay. All right. Okay. Let's talk about the next one. Okay. So, if I think about plugging in, zero for this one, okay, I'm going to get the square root of 25 minus 0 squared minus 5, which is going to be square root of 25 minus 5, which is 5 minus 5, which is 0. And then the bottom, obviously, what am I going to get? 0, right? So you can do scratch work like I've done over here. Again, I would avoid doing like that this equals, putting the equal sign there. But then if you have done scratch work, instead of doing like the proper limit notation, you can say is of the indeterminate form 0 over 0. So rather than saying it equals 0 over 0, we're saying it is of the indeterminate form 0 over 0. So we can do limit as x approaches 0. So that's your other option other than doing the limit of the top and bottom separately. So we got square root of x. Alright, we're going to take the derivative of the top and the bottom. So this is like 25 minus x squared to the 1/2. Who can remind me how to take that derivative? Chain rule. It's going to be, what is it going to be, Jeremy? Almost negative 1/2 right there. You need. Okay. So that's the derivative of the top. Derivative of 5 is just 0. It goes away. What's the derivative of the bottom? 1. Okay. So for this, if we want to clean it up a little bit before we plug in, or you don't have to, but I like to. So that's going to be negative x times 25 minus x squared to negative 1/2, which I'm going to write as negative x over the square root of 25 minus x squared. Okay, so when I plug in here, I'm going to get negative 0 over square root of 25 minus 0 squared. What is that going to give me? 0 over 5, which is 0. So that feels kind of wrong to get 0 as the answer. It makes you feel like it's not working out. But this time you're not getting 0 over 0. You're getting 0 over a number, so that is 0. Correct. Right. 0 over another number is fine for that. Okay. So if we look at number 4, I've got the limit as x approaches 1 of x to the 11th minus 1 over x to the 4th minus 1. If I plug in 1, I will get 1 to the 11th, which is 1, minus 1, 0, right? And 1 to the 4th, which is 1, minus 1, which is 0. So this is going to give you 0 over 0. That one's a pretty simple plug-in in your head kind of problem. So I think it's going to be okay if you just say is of the indeterminate form 0 over 0 without showing any work of how you plug that in. I forgot to put by L'Hopital's on the last problem. By L'Hopital's rule. So by L'Hopital's rule, the limit as x approaches 1 of x to the 11th minus 1 over x to the 4th minus 1 is going to equal 11x to the 10th. Oh, wait. Ooh, this is bad. What am I doing wrong? Limit notation. I got to keep it. If this is a free response question, don't lose your limit notation. Limit as x approaches 1 of 11x to the 10th power over 4x to the 3rd power. And if you plug in 1, you will get 11/4 for that. Okay, questions so far? All right, let's see what's going to be best to look at. All right, let's do 8, and then if we got time for that, we probably don't have time for another one. Let's do 8. Okay, the rules are going to be the same for the other. You check to see if it's 0 over 0. You take derivative of top and bottom. It's going to throw in some derivatives we hadn't seen in a while, some trigs, some stuff like that. So you have to think back to those. You also are likely to possibly get something crazy like this, and we're supposed to find the limit as x approaches 0 of all this stuff. You have to use L'Hopital's rule for this. Because if you don't, you're not going to be able to take the derivative at all. Or the limit at all. So for this, I'm going to do limit of top and limit of bottom just because I'm going to have to think about this a little bit. It's not an easy plug in your head, so I'm going to do it this way. But you can do it as you will. Oh, wait. Yes, I need an x here for my limit notation. So f of x e to the x plus 4 is going to be 2 times f of 0 e to the 0 plus 4. What is f of 0? Negative 2. What's e to the 0? 1. And we're going to get 0 for that top, which is what we want. Otherwise, we can't use L'Hopital's rule, right? And if we're doing 3x squared minus 3x, we are going to get 3 times 0 squared minus 3 times 0, which also equals 0. So by L'Hopital's rule, we can say that the limit as x approaches 0 of 2f of x e to the x plus 4 over 3x squared minus 3x is going to equal, we're going to take our derivative. So we'll have the limit as x approaches 0 of, what have we got to use to take the derivative of 2f of x times e to the x? Product rule. So you're going to have 2f of x times the derivative of e to the x, which is e to the x, plus e to the x times the derivative of 2f of x. What's that? 2f prime of x. And then I need to take the derivative of that plus 4, but the derivative of 4 is just 0, so that's going to go away on the end. That's the derivative of the top for us. And then we've got 6x minus 3. And so now we want to plug in that number. If you want, you can factor out 2e to the x. It really doesn't matter. Let's just plug in. We got 2f of 0 times e to the 0 plus e to the 0 times 2f prime of 0 over 6 times 0 minus 3. Once you plugged in your number, you can drop your limit notation. And we already found f of 0, it was negative 2. E to the 0 is 1. What's f prime of 0? It is -1. Where'd you get that, Luke? There is, and its slope is -1. Very good. And then we're getting a -3 on the bottom. Technically, for response, you could stop here, and I wouldn't blame you if you did, but we're going to go ahead and finish it out. -4 minus 2 over -3 is going to give us -6 over -3.